Okay, so this is the start of section 2.7, and 2.7 is all about transformations. But in order to apply transformations and really talk about what that looks like, is we really need to know our vocabulary. So a family of graphs, kind of exactly probably what you're thinking. It is a group of graphs that display one or more similar characteristics. Right? So they display one or more characteristics. Hopefully that actually looks like characteristics. So most basic example we can think of. If we have the line y equals x, try and make it go through. So it's y equals x. All right, so this line is the most basic of this family. So that's what we call the parent function. It is the simplest of the graphs in a family. And what we can do then is we can take this most basic y equals x, and we can start looking at, well, what happens if I added 2 to it? So then I would have the line y equals x plus 2. What happens if I suddenly multiply by a negative or something like that? I could have the line y equals negative x minus 2. So these are all very similar graphs, but they're just slightly altered. So the most basic was our y equals x. That is what we would call the parent function of this family. And all the others are transformations of that original function. All right, so these are all linear. They are the linear family. All right, now the next three definitions are special types of families of graphs. So there's a constant function. So what does it mean to be constant? You don't change. So the constant function is a form of x equals a, where a is any number. So we've talked about this slightly when we were graphing piecewise functions. If I had the line y equals 2, that is a constant function. Doesn't matter what x is, no matter what, y is constantly 2. All right? Anytime you just have like y equals or f of x equals some number, that is a part of the constant family. It is a constant function. The identity function actually, so if you have f equals x, it passes through any ordered pair AA. Well, that's really right here your linear function. So another way to refer to your linear function is to call it the identity function, right? It's always of the form f of x equals x or y equals x. So if you plug in 2, you get 2. You plug in negative 10, you get negative 10, right? So that's your linear family. It's also called your identity family, right? So we have constant, which is just horizontal lines, and we have the identity functions, which is just your linear lines. Oh, passes through, has an H. The last function we're going to talk about. So that is of the form f of x equals x squared. It is a parabola. All right, so if I plug in 0, I get 0. 1 or negative 1. Either of them squared is the same thing. If I plug in 2 or negative 2, if I square them, I'm up at 4. So it is a parabola. Notice that it is a curve. This is not like an absolute value function where it comes to a point. It is a curve. Right? And what happens is we take these parent functions and we apply what we refer to as transformation. So all of these are types of transformation. Right? So maybe I add 2, maybe I multiply by something. Something like that is going to shift my graph slightly. So a translation moves a figure up, down, left, or right. All right, so that's probably what you referred to in the past as a slide. Just moves it either up, down, left, or right. A reflection flips a figure over a line. And the line that it flips over is called the line of reflection. All right, so you could reflect it over the y-axis, the x-axis, really any line. So if I took, I don't know, a parabola here and I reflected it over the x-axis, then it would be down here. Right? And finally, a dilation. Well, a dilation either shrinks or enlarges a figure proportionally. So it's not just going to, pull it one direction or stretch it on one side or shrink it. It will affect the entire figure proportionally. Right? So these are all really important terms that we need to know as we continue with the next videos. So what we're going to talk about is we have these families of graphs. Well, what happens if we apply some of these transformations to them? We're going to talk about some general rules and things like that in the next couple of videos.